Hello students. So in this video, we're going to start with trigonometric identities and problems based on it. A very important concept. So let's start with trigonometric identities. Identities. Okay. There are three very important identities. Okay. See, the difference between the formula and the identity is applicable everywhere. Okay. Formula is specifically applicable only in certain place. Okay. So coming to the first identity, a very important one, sine square theta plus cos square theta is equal to 1. Okay. So let's try to prove this. Okay. Let's take the LHS. What's the LHS? See, in all the proving sums, we don't take the LHS and RHS together. Okay. The thing is, we are trying to prove it, right? So we have to take the LHS or the RHS separately, then solve it and try to end up at LHS or RHS. Okay, now I'm taking the LHS. So I'll try to solve it and end up at RHS. That is, I'll try to get the value 1. Okay, so what is the LHS? Sine square theta plus cos square theta. Let's take a right angle triangle. Okay, let's say it is A, B, C. This is 90 degree. Let's say C is theta. Now we know that opposite to 90 degree is hypotenuse and opposite to the given angle is the opposite side, and the other one that is left out is the adjacent side. Okay. Now, according to the definition, sine square theta is what? Opposite by hypotenuse, isn't it? So opposite by hypotenuse. Since it is square, let's square it. Okay. And what is cos theta? Adjacent by hypotenuse, the whole square. Now what is opposite from the figure? It is AB and hypotenuse is AC. AB by AC the whole square plus BC by AC the whole square. Now since here AB and AC are in division, okay, we can split the squares, the power. So it becomes AB square by AC square plus BC square by AC square. Now if you observe, the denominators are same, isn't it? The denominators are same, therefore we can write it once AC square. The numerator will become AB square plus AC square. But according to AB square plus BC square. But according to Pythagoras theorem, we know that if you apply Pythagoras theorem for this triangle, we get what? AC square is equal to AB square plus BC square. Therefore, AB square plus BC square can be written as AC square. So the denominator is also AC square. Both gets cancelled. We are left with 1. Okay. This is the proof of this identity. Okay. Which is not required, but let's understand how did we get this identity. Okay. So very important one. Sine square theta plus cos square theta is equal to 1. Okay. Then using this, we can derive some more. Okay. That is, see, I'll transpose or I'll shift this sine square to the right hand side. So what happens? You get cos square theta is equal to 1. Sine square theta comes this side, it will become minus sine square theta, isn't it? Therefore, I can write it as cos square theta is equal to 1 minus sine square theta, or the other way. Okay, so the second one will be 1 minus sine square theta is equal to cos square theta. The same thing, if you shift cos square the other side, it becomes 1 minus cos square, isn't it? And what is left out? Sine square. So 1 minus cos square theta is equal to sine square theta. If you remember the first one, you can easily remember the next two. Okay. Now coming to the next very important identity. Okay. 1 plus tan square theta is equal to secant square theta. You can prove this identity in the similar fashion which we did. Okay. 1 plus what is tan theta? Opposite by adjacent. So it is square, so square it. So it become 1 plus opposite square plus adjacent square. So if you take LCM, it becomes adjacent square plus opposite square by adjacent square. Adjacent square plus opposite square is hypotenuse square, isn't it? So hypotenuse square by adjacent square. So both are square, so you can make it as whole square. Hypotenuse by adjacent, the whole square. Hypotenuse by adjacent is what? Secant theta. Since there is a square, it becomes secant square. Okay. So you can do this, try it out. Okay. And you have done it. Now shift 1 to the other side. It becomes secant square theta minus 1, isn't it? So secant square theta minus 1 will become what? Tan square theta. I'm just shifting 1 to the other side. If I get the 1 to the other side, you will have it like this. Tan square theta is equal to secant square theta minus 1, or the other way, secant square theta minus 1 is equal to tan square theta. Similarly, instead of 1, if you shift tan square to the other side, it becomes secant square minus tan square. That will be equal to what? 1. Okay. A very, very important. Now, see the first three, the first one, the fourth one, if you remember the first one, you can remember the second one, third one. If you remember the fourth one, you can remember the fifth and sixth. Similarly, coming to the seventh one, okay. Now 1 plus cos square theta is equal to cosecant square theta. In the same fashion, cosecant square theta minus 1 will become cot square theta, and cosecant square theta minus cot square theta will be equal to 1. Okay. These are the 9 important identities which we'll be using to solve the problems. Okay. If you remember this 9, you need not remember all the 9. If you remember the first one, fourth one, and seventh one, that's more than enough. You can get the others. Okay. If you remember this identities, easily you can solve problems. And for the state board students, 3-mark question, a compulsory 3-mark question will appear in the exam for on this topic, that is trigonometric identities. Okay. Now let's say the rules to solve. Okay. Okay. What are the rules? How do we solve? See, there is no particular pattern. Okay. We have different types of problems here. That's what makes it a bit difficult. Students feel a bit difficult in this concept. Okay. In the entire trigonometry chapter, this is a bit difficult. Okay. Now, if you follow this 4 rules, which I'm going to give, the problem will become much easier. Okay. The first rule is check for any trigonometric identities. Or let me write, check if any trigonometric identities is there. Check if any trigonometric identities are there. See, the first step is always to check. Okay, in the given question, you have to check whether any trigonometric identities are there. Okay, we can also check for algebraic identities. When I say algebraic identities, a plus b whole square, a minus b whole square, a square minus b square, a cube minus b cube, all these are algebraic identities. Okay. Now, the first step is always, you will take the question and you will check if there is any trigonometric identities. Okay, if it is there, you're going to use it. Okay, and when you use it, easily you will get the answer. Okay, this is the first step. If trigonometric identities are not there, if trigonometric identities, T dot I, trigonometric identities are not there, then convert all the ratios, convert all the trigonometric ratios in terms of sine theta and cos theta. Okay. So you have to check if there is any trigonometric identity. If it is not there, okay, the question doesn't contain any trigonometric identity, Then what you're going to do is you're going to convert all the trigonometric ratios, that is secant, cosecant, secant, cosecant, cot, tan, everything into sine theta and cos theta. Okay, if you convert in terms of sine theta and cos theta, okay, it will be very, very easy. The next step is, after you convert it into sine theta and cos theta, definitely 100% you must take LCM. Okay, you must take LCM. Take LCM and simplify. Take LCM and simplify. Now, once you simplify it, after simplification, definitely, okay, after simplification, definitely you're going to get some trigonometric identities. After simplification, we will get trigonometric identity or algebraic identity. Okay, so after simplification, definitely either you're going to get this 9 trigonometric, out of this 9 trigonometric identity, any one you're going to get, or algebraic identities like a plus b whole square or a square minus b square. The most used is a square minus b square. Okay, this is the identity that you will get, or a cube minus b cube, or a cube plus b cube. These three are the most identities that you get after simplification. Okay, now very, very simple 4 rules. Okay, as soon as you see the question, check any trigonometric identities are there. If it is there, use it. If it is not there, okay, also you can also check for algebraic identity also. If it is there, use it. If it is not there, you're going to convert everything into sine theta and cos theta. Once you convert it into sine theta and cos theta, you must take LCM. Okay, you must take LCM and simplify it. Once you simplify it, definitely you will get a trigonometric identity or an algebraic identity, either this or that. So use that trigonometric identity or algebraic identity, you will get the final answer. Okay, if you follow these 4 steps, the problems are going to become much more easier. Okay, students, so let's start with the problems. I've taken the very important questions. Okay, the first 2 questions I've skipped it from the exercise. Okay, now let's solve this. Evaluate sine square 63 plus sine square 27 degree divided by cos square 17 degree plus cos square 73 degree. See, one thing is very sure, that this is not a problem based on standard angle, because there is no standard angle. What are standard angles? 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. These are standard angles, but we don't have these angles there. So we must use complementary angles concept, isn't it? So what we are going to do is, in the numerator, if you observe, in the numerator, there are 2 terms, isn't it? So we'll keep any one term as it is and we'll change the other. Okay. Or you can also do it like this. You can keep, you can change both the terms in the numerator and don't do anything in the denominator. Okay. You can also do it like this. This is how we solved, isn't it? If you have not watched the complementary angles concept, please check the video, the previous video. See, in complementary angles, what we did was, we changed the numerator and we kept the denominator as it is. Here also you can change the numerator and you can keep the denominator as it is and you can solve it, but we'll do it in a bit different way. What we'll do is, in the numerator, if you observe, there are 2 terms, isn't it? So we'll keep one term as it is, we'll change the other one. Okay, sine square 60 degree. Or if you remember, sine theta can also be written as cos of 90 minus theta, a very, very important. Okay, or the other way, cos theta can also be written as sine of 90 minus theta. Okay, using this problem, using this formula, observe sine square 63 degree. Now forget about the square. Sine 63 degrees, that can be written as cos of sine theta. Here theta is 63. Okay, sine 63 can be written as cos of 90 minus 63. Okay, now since it is square, let's square it. That's it. That's all we are going to do. Okay, plus sine square 27 degrees as it is. Okay, now the denominator, even in the denominator, we'll change the first term. Cos 17 degrees, cos theta can be written as sine of 90 minus theta. Here theta is 17 degree. Since there is a square, let's square it. Okay. Plus the other term as it is, cos square 73 degree. Now, the numerator cos square 90 degree minus 63, that will become 17 degrees, isn't it? Plus sine square 27 degrees divided by sine square 63 degrees plus, sorry, sine square 73 degrees plus cos square 73 degrees. Okay. Now, initially I told you can do it the other way, like you can keep the denominator as it is and change both the terms in the numerator. That is a bit wrong. Okay, you cannot solve further because the angles are different. Okay, so what we can do is the method which we are doing. Okay, that is a bit wrong. I'm sorry about that. You have to do it like this. Okay, what we are going to do is, in the numerator there are two terms. We're going to keep one as it is. We're going to change the other one. In the denominator there are two terms. We're going to keep one as it is and we're going to change the other one. That's what we have done, isn't it? Now if you observe, we have got an identity here. Cos square theta. See, in place of theta we have got 70 degrees. Observe the numerator. Cos square theta plus sine square theta. So we know an identity which says that cos square theta plus sine square theta, or the other way, sine square theta plus cos square theta. Both are one. Okay. So if it is an addition, you can interchange, no problem. Addition is commutative, meaning 2 plus 3 is same as 3 plus 2, isn't it? So sine square theta plus cos square theta is 1, or cos square theta plus sine square theta is 1. Both are same, isn't it? So what we have got is, here in the numerator, cos square 17 degrees. Okay, this must be 27. I'm sorry. Yeah. Cos square 27 degrees plus sine square 27 degrees. What do we get? Cos square theta plus sine square theta, 1. Similarly, in the denominator, sine square theta. Observe the theta 73. Okay, both the angles must be same. You have to be very careful about it. So sine square 73 degree plus cos square 73 degree. It's like sine square theta plus cos square theta. What is the answer? 1. So 1 by 1 is 1. So the final answer is 1. So remember, in this problem, what we have done is, we have changed one term in the numerator and changed one term in the denominator. Then we have used the identity, that is sine square theta plus cos square theta is equal to 1. This is the identity that we have used. Okay. Now let's get into the next problem. Even in the next problem, we're going to use the same logic. Okay. There are two terms. Okay. There are two terms. The second question, sine 25 degrees cos 65 degrees plus cos 25 degrees sine 65 degrees. Now, usually when we add two terms, if you remember in the complementary angles, we used to change one term and we used to keep the other term as it is. But here, what we are going to do is, see here, if you observe, 25 and 65 are complementary, isn't it? 25 and 65 are complementary. So therefore, in this, we are going to change any one and keep the other one as it is. Similarly, here in this, we are going to change any one and keep the other one as it is. So basically, what we are trying to do is, we are trying to get it in the form of sine square theta plus cos square theta. So that the final answer will be 1. So what I'll do is, sine 25, I'll keep it as it is. I'll change this cos. Okay. So cos theta can be written as what? Sine of 90 minus theta. Plus, here, observe, this will become sine square. Okay, here, I'm sorry. Let's keep cos as it is. Let's change this sine 65. Okay, sine theta can be written as what? Cos of 90 minus theta. I'm sorry. Let me erase it and rewrite it. Cos 25 degrees. Sine theta can be written as cos of 90 minus theta. Okay. Or I can say it in other words. Here we change 65. Here also let's change 65. That will be the best. Okay. So sine 25 degrees into 90 minus 65 is also 25. Sine 25. plus cos 25 degrees. 90 minus 65 is 25. So what is happening here is sine 25 into sine 25. So it will become sine 25 the whole square, or sine square theta, sine square 25 plus cos square 25. Now it is exactly like sine square theta plus cos square theta, which will give us 1. I hope this is clear. So let's get into the next question. So in the next question, choose the correct option and justify your choice. Okay. So the first question is, and the first question is 9 secant square A minus 9 tan square A, isn't it? If you observe carefully, I can take 9 as common, isn't it? We can take 9 as common. Therefore, we are left with secant square A minus tan square A. Now, do we have an identity like this? Secant square A minus tan square A, or secant square theta minus tan square theta. Okay, in place of theta, you can also have A, B, C. Doesn't matter. If you observe the sixth formula, secant square theta minus tan square theta. Or I can also say secant square A minus tan square A. What will be the answer? The answer will be 1, isn't it? So instead of theta, we are having A. That's it. So therefore, secant square A minus tan square A is what? 1. So 9 into 1 is 9. So what is the identity that we have used? Secant square A minus tan square A will be equal to 1. That is the identity that we have used. Therefore, the correct option is option B, 9. Okay. So in the next question, okay, it is 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. Okay. So let's do this. Okay. 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. See, again, this is a problem based on trigonometric identities itself. Because there is no complementary angles, no standard angles, no trigonometric ratios. So it's basically we have to find the value of this, isn't it? So we have to use the identities concept. Now, as I told you, the first step is always to check if there is any identities. As you can see, there is no identities. Remember, we have got an identity which says cosecant square theta minus cot square theta. But here we have got cot theta minus secant theta. So this is not an identity. So basically, there is no identity over here. So if there is no identity, what should we do? We have to convert all the trigonometric ratios in terms of sine theta and cos theta. So if you remember tan theta, that is the quotient relation. If you remember that, tan theta can be written as sine theta by cos theta. Now plus secant theta can be written as, using the reciprocal relation, it can be written as 1 by cos theta. Very, very important, the reciprocal relations and the quotient relations. Okay, please recall that. Cot theta can be written as cos theta by sine theta minus cosecant theta can be written as 1 over sine theta, because cosecant theta and sine theta are reciprocal to each other, isn't it? If you observe these two terms, I've got same denominator, isn't it? So let's do that. Let's combine that. So 1 plus, or it will become sine theta plus 1 divided by cos theta. Even here, these two terms have got same denominator. So let's do that. Let's combine it. So it will become sine theta once. The numerator will become cos theta minus 1. Now, as I told you, once you convert it into sine theta and cos theta, you have to take LCM. So this one can be written as 1 by 1. Here also this one can be written as 1 by 1. So let's take the LCM. Here we're going to use the shortcut method. Okay, to make the easy, we'll multiply the denominators. So 1 into cos theta, then crisscross. 1 into cos theta is cos theta, plus 1 into anything is same thing. So 1 into sine theta plus 1 is sine theta plus 1. I hope this is understood. We have to multiply the denominators and crisscross. Numerator with denominator, denominator with numerator. Same thing applies here. 1 into sine theta is sine theta. Crisscross. First I multiplied the denominator. 1 into sine theta, sine theta. Now the numerator and denominator. 1 into sine theta is sine theta plus 1 into cos theta minus 1. This is what actually we have to do, but 1 multiplied by anything is same thing. Okay, so it becomes cos theta minus 1. Now if you observe carefully, in the first bracket, let's just change it. Cos theta plus sine theta, let's just write it as sine theta plus cos theta plus 1. Doesn't matter, isn't it? Cos theta, numerator will become sine theta plus cos theta minus 1 divided by sine theta. Now if you observe carefully, let me put square brackets. What I'll do is I'll consider this sine theta plus cos theta as one term. Okay, let me consider this sine theta plus cos theta as one term. Now if you observe carefully, this entire thing is one term, right? Let's say it is a plus b. Here also this is a minus b. If you observe the numerators, it is in the form of a plus b into a minus b, where your a is sine theta plus cos theta. A is sine theta. This entire thing I am taking it as a. This entire thing we are taking it as a. Okay, so a plus b, a minus b. What is a plus b into a minus b? As I told you, once you convert it into sine theta, once you take LCM, definitely you will be getting what? Identity. Here we have got a plus b into a minus b. So I'm sorry, a plus b into a minus b is a square minus b square. Here our a is sine theta plus cos theta, isn't it? That is our a. A square minus our b is 1 square, divided by the denominators we have to multiply because they are in multiplication, right? So cos theta into sine theta will become cos theta sine theta. Now let's simplify it. Okay, let me do it here. Okay, it will be better if I do it here. So if you observe, it is the sine theta plus cos theta the whole square. It is in the form of a plus b the whole square. So let's use that. A square in the sense sine theta the whole square, isn't it? A sine theta. So a square. What is our b? Cos theta. B square. A square plus b square plus 2ab minus 1 square is 1. Okay. The sine theta the whole square can be written as what? Sine square theta, isn't it? And cos theta the whole square can be written as what? Cos square theta. That's what we are going to do. Okay. Divided by the denominator cos theta sine theta. Now, if you observe the numerator properly, we have got here sine square theta plus cos square theta, isn't it? So sine square theta plus cos square theta is 1 plus 2 sine theta cos theta minus 1 divided by cos theta sine theta. Now plus 1 and minus 1 gets cancelled. So we are left with 2 sine theta cos theta divided by cos theta sine theta. Everything is in multiplication, so you can cancel it. Cos theta gets cancelled. Sine theta gets cancelled. So we are left with 2. Okay. So the correct answer is 2. This is the justification. Okay. So if you observe carefully, what we have done is we didn't have any trigonometric identity in the question. So we converted everything into sine theta and cos theta. Once we converted into sine theta and cos theta, we took LCM, isn't it? After taking LCM, if you observe carefully, what we had is, we had, let's take this as A, isn't it? This is what we took it as A, isn't it? So this is the form of A plus B, A minus B. A plus B into A minus B is what? A square minus B square. So we use A square minus B square, and the denominator cos theta into sin theta is cos theta sin theta. Then again, if you observe the numerator, it is in the form of A plus B whole square. We used it. We got the final answer as 2. Okay. So this is how we get the answer. So let's get into the next question. Let me erase this.